Hello everyone. In today's video, I will discuss about equipartition principle and heat capacity. Though this chapter is included in kinetic theory of gases, but as CV is there, so I will discuss this under thermodynamics. So let's start with first question. The value of CV for 1 mole of nitrogen gas predicted from the principle of equipartition of energy ignoring vibrational contribution. What is CV? CV is heat capacity at constant volume. CV is equal to du by dt at constant V volume. U is equal to internal energy. From kinetic theory of gas, we know that gas molecules are randomly rotating, randomly moving, and they don't have any potential energy. All their energies are kinetic energy. And equipartition of principle statement is average kinetic energy associated with each molecule with each degree of freedom is half kT. So we have to find the degree of freedom for nitrogen molecule. Nitrogen molecule is molecularity is 2. So translational energy or translational degree of freedom 3, because half mv x square plus half mvy square plus half mvz square. Now rotational degree of freedom. Rotational degree of freedom will be 2. Why 2? Why not 3? Because if this is a molecule, if this is a diatomic molecule, then its rotation should be, this is n, this end one end, and this end another end. Its rotation should be like this. One rotation is like this, another rotation will be like this, another rotation will be like this. Another rotation is x-axis, small r. So this r, that means the radius is very small. This is along x-axis rotation, this is very small. So half I omega square, half I omega y square plus half I omega z square. Omega x square, half I omega x square is equal to 0 for linear molecules. As nitrogen is linear molecule, so rotational degree of freedom should be 2. This 2 is molecularity. So total degree of freedom is 5. We are not counting the vibrational contribution, only rotation plus translation. Now each degree of freedom will contribute half kT. So U is equal to 5 by 2 kT. This is nitrogen molecule. So into N. N is Avogadro number. is equal to 5/2 RT. Therefore, du dt at constant V is equal to 5/2 R. What is the value of R? The value of R is given 8.3 joule per Kelvin per mole is equal to 5/2 into 8.3 joule Kelvin inverse mole inverse is equal to 20.75 joule Kelvin inverse mole inverse. So the right answer should be 20.75. Now come to the second question. The molar heat capacity at constant volume of a gas is 25 joule per mole per Kelvin. At room temperature, the gas must be nitrogen or oxygen or carbon dioxide or SO2. So CV is given as 25 joule mole inverse Kelvin inverse. From last question we know CV is equal to du dt at constant V is equal to degrees of freedom by 2 R is equal to 25 joule mole inverse Kelvin inverse. Now if here F is equal to, after calculating, F is equal to 6 without vibrational contribution. For linear molecule, 3 translational degrees of freedom plus 2 rotational degrees of freedom. Total degrees of freedom is 5. For non-linear, 3 plus 3. Rotational contribution should be 3. So, total should be 6. Here, nitrogen is diatomic, linear, oxygen linear, carbon dioxide linear, SO2 is non-linear. So, SO2 should be the correct answer. Thank you for watching.